Hi, and welcome to our first set of video lecture notes. So you should have your Cornell Notes template or have your paper set up to take Cornell Notes. And at the top, you need to write the topic, which is problem solving and the scientific method. And next to that, you need to write the date so that way you can keep your notes in chronological order in your binder. I just wanted to make a quick note on actually taking notes. The reason that we take notes in class is to build strong connections between your neurons in your brain. And this is because it's been shown that if you see it while it's on the screen, you hear it while I'm speaking to you, and then you also write it down, that you'll actually build stronger connections between the neurons in your brain that will relay this information into your memory. So there's been many scientific studies to show that overwhelmingly writing something down is really the best way to synthesize it. And this is better to actually handwrite it than it is to type it or to read it only. So that's why we're doing this by hand. So we have 6 different processes in science that we're going to talk about. And so right now in the left side of your Cornell notes, you should write down 6 basic processes. And on the right, you should write that they have a variety of combinations and that they're used to solve problems and answer scientific questions. So our first basic process in science is observing. So you're going to want to write down the word observing on the left, and then write down the definition on the right, which is one or more of our 5 senses that are used to gather information. And these observations must be factual and accurate. It's really important to keep careful records when you take observations. And right now on our screen, you can see 2 examples of organisms taking observations, some people out in the woods watching something, and a cat observing a fish. Our next basic process in science is inferring. So on the left side of your paper, you should write inferring, and on the right, you need to write explain or interpret an observation. And so inferring can be confusing sometimes, particularly with our next process in science, which is predicting. But with an inference, it's more about something happening in the present. So if you hear your dog bark, you can infer that there's someone at the door. And this is based on the evidence that in the past, when you've heard your dog bark, it's been because there's been a stranger at the door. The only way to find out if this inference is correct is to actually go out and investigate further. So maybe go to the door, see if that's why your dog is barking. The next basic process is predicting. And this is when we make an inference about the future event based on current evidence or past experience. So a really good example of this is predicting the weather. That's why I have a picture of lightning. So the main difference here between inferring and predicting is that predicting has to do with the future. Next, we have classifying. So on the left side of your paper again, you need to write down the word classifying. And on the right, write the definition. A group things together that are alike in some way. Scientists love to group alike things together. It's usually easier for them to categorize and understand. Our next process is making models. So on the left, you're going to write making models. And on the right, you're going to write that it's usually to examine something that is too large or too small. So for example, here I have a model of the solar system, which would be too large in reality to actually put inside of a room. So people often make models of the solar system to better visualize it. And then I also have a model of DNA. So DNA is too small, even with a microscope, to be able to see clearly the atoms and molecules that make up DNA. So we often make a model of it to better understand how its structure is related to its function. Our last basic process in science is communicating. It's really important that scientists share their ideas and that they're good at writing or figuring out how to say things to people. They need to share their results with both other scientists and with people who may not be scientists. So having a good skill of communicating is very important. Now to talk some more about problem solving. So when we take observations, there's two types, qualitative and quantitative. We're going to first talk about quantitative observations. So these are generally going to be things that have numbers in them. So on the left side, you should write quantitative observations, and on the right, write down that they generally have data that has to do with numbers. You should also know that it's very important to keep track of your units. On the previous screen, I listed some units that you would use to take quantitative observations. If you mistakenly mislabel your units, it can have very serious consequences. And in class, we'll talk about two instances where these issues were very bad, one for NASA and one for Disney. You can also have qualitative observation, and this is when data is collected in the form of descriptions. So really careful notes, maybe photographs, movies, but this is more about observing something happening, and it generally doesn't have numbers in it. Next, we're going to go over the scientific method. I know that this is something you've probably learned before. However, it is a simplified version of what scientists actually do. We talked a little bit about this in class already. So step one is generally to ask a question. You make an observation, state a problem, and ask a question you want to know the answer to. Step two is to do your research. Think about what it'll take to solve the problem. What do I need to know? And what do I already know? So maybe go and actually do some research online, read some papers, figure out more about it. Step three is to form a hypothesis. So this is an explanation for something that has been observed, and it's based on evidence. Step four is that you test your hypothesis. So you're going to actually perform an experiment to see if your hypothesis is correct, or at least not incorrect. Step five is that you're going to analyze your data. So actually look at it, see if it supports your hypothesis or not. Step six is that you're going to draw some conclusions from your data. So you're going to look at the logical answer to the original problem and use your data to support it as evidence. As we talked about in class, scientific inquiry is really a more appropriate term for what scientists actually do. Science isn't a linear process. There's no real end. And so the scientific method tends to simplify it down a little too much. So the real process of science looks more like the picture on the right side of your screen. It can take many different paths. It's never ending. And it just kind of bounces around like a pinball machine. So go ahead, double check your notes, rewatch the video, make sure you didn't forget anything, and that you can answer all the questions on the review notes. Otherwise, you need to go back, include some more stuff in your notes, and then don't forget to write your summary on your Cornell notes sheet.